All right, I think we can get started. Jaihan, can you hear?
Yes.
Okay, so first some um Chemnitz trivia. So because of daylight savings time, I guess this is moving to an hour earlier. Is that a problem to you guys?
Sorry, I forgot the time. I still
Oh
think
no,
this. Sorry.
I was going to say sorry. I know it's a giant pain for everyone. I was asking, is it a problem for it to move earlier though for you guys? Are you
No,
guys
no
able to?
problem from me.
Okay,
No, no for me.
cool. Then that's what the time will be till the fall. I don't have much to report on the Crimson side. I did a couple reviews, but mostly I was doing a Crimson talk at scale last week and work on Scrub. Yingxin?
Yeah, I have reviewed and merged the CodeTier PR, and I think that the design of the read optimized device tiering should be aligned now. And I'm also reviewing the multi-core Seastore and the adjustments to the futurized store interfaces, and also reviewing the lazy read feature in the data override, object data override. That's all for me.
Okay, Shreya?
This week I was still mostly modifying the LBA pointer PR as Yingxin suggested. And we also tried to design the machinery for cloning in Seastore, but I think that's a large part we are missing for the design, and that is snap trimming and snapshot recovery. Is that right?
Yeah, so the most common, the, you're correct in that the most common write pattern is that you clone head to a snap ID larger than any previous snap ID and then write to head. That is indeed the most common pattern most of the time. However, recovery doesn't work that way. During recovery, when we're serving a read or a write, we will try to recover whichever object is being read or written immediately because it blocks the IO operation. So if we get an IO on head, which is normal, before it has been recovered, we're going to recover that head object immediately. We're not going to recover the clones first. Then we'll then recover the clones backwards from that, well, in whatever order they happen to come up. The OSD maintains metadata in the clone subsets, I think, struct or map in the snapset. And when it submits the IOs to actually write out each clone, it will do a clone range to clone the portions of the object that it shares with its neighbors. So unfortunately, you have to tolerate that. Either you have to tolerate that, which I think you actually do because we have good reasons for it. It reduces latency during recovery. Or you'd have to change the way the OSD does recovery. On a larger sort of architectural, and the other piece is that when we're trimming snapshots, it's extremely uncommon to remove snapshots in the order in which they were created. Usually, like one super common pattern is people will take hourly, daily, and weekly snapshots. So you'll have some snapshots last for a very long time with snapshots between them that are only very briefly alive. So you need to support removal of snapshots in any order, and that's common operation. So not only does that have to be supported, it has to be efficient. And it shouldn't result in fragmentation, at least not an unreasonable amount of it. Does that make sense?
Uh, yes. Uh, Actually, I haven't given this given the recovery and snap trimming very careful thoughts. But it appears to me that if we can right now in our design we only record the most recent clone objects snap ID and object data object data in the head object. But I think we can no matter head object or a clone object, we always keep the nearest snap ID and object data within the O node for the most recent clone object before it. I mean,
It forms a singly linked list, right?
yeah, and that seems to be able to resolve the issue around snap trimming and recovery. But I'm not sure
Maybe,
if this
but
is true.
I don't think so. I think the end result will be that it'll be really complicated, and you'll be mixing the ref counting portion from just being something that object data handler and the ladder layers need to worry about to something that the O nodes need to worry about too. I think the end result will be much more complicated.
Okay.
Um, if
Sam,
you
are
did
you
want to use, oh, go ahead.
Okay. My thought is that Johan's point is that trying to not complicate it, the back reference tree to be a one-to-n relationship. So I think using the L address redirection, that is also possible.
Yeah, that actually does make sense. So my suggestion is that each one of these ranges will be owned by some ladder range, and then when it gets cloned to another object, that object's object data handler, instead of referring to those logical addresses directly, or those physical addresses directly, will have an indirection back to the old one. In other words, you're still going to build something a bit like a linked list, but you'll do it in the object data handler instead of in the O node. And it'll need to be, you can't make strong assumptions about clone ordering, because like I said, the clones may not all even exist at the same time, because recovery might happen in any order. But you can probably create some kind of extent that acts like the blob concept in BlueStore, where when you have multiple objects referring to the same extents, instead of referring to those extents directly, they instead refer to this indirection, and that indirection is what owns them. So the backref would point at that indirection instead of at the original object data handler regions. Does that make any sense at all?
Okay, I'll try to give it more careful thoughts.
So in other words, like when you clone an object, you would take all of its regions, and the new clone would refer back to that ladder via a secondary extent, or a special ladder entry that references the old one. Was that something like what you had in mind, Yingshin?
Yeah, I think that's similar.
There's more than one way to structure it. I don't really have a strong opinion yet, but
Mhm.
something like that probably is the way to go. Like if you need more space than you can fit in the ladder tree, then you could create an extent with that purpose. Something like that. Anyway, it's something to think about a bit more, I think.
Yeah.
Have you looked at how BlueStore does it?
Not quite. I was mostly trying to understand how the classical SD's PG layer handle the clone operation. I didn't pay much attention to BlueStore. I think that I should go into BlueStore later. I mean, then the next step should be look into the BlueStore.
Yeah, probably. I think the way it does the indirection is a simple solution that will likely work well for us, at least for now.
Okay.
In that it uses an indirection like Yingjun is talking about. It'll be different in Seastore because we have an LBA layer, but conceptually.
Yeah, I think I don't quite understand the L address indirection right now, but I think I can discuss with Yingxin later.
Yep.
Yeah, because I think maybe it'll be more effective if we communicate in Mandarin. I'm sorry about that. I'm quite
No,
good
that's
in.
perfectly reasonable. I understand.
Okay, thanks. Really sorry.
Oh yeah, no worries. All right, is there anything else?
No.
All right, later. Have a
You-
good week.